Hello guys, welcome back. In this video, let us understood one more important concept, that is numerical precision. If you are going to train a model or if you are going to selecting a model, then it's very important to consider this numerical precision parameter. If you consider this, then only you can utilize your storage effectively. Okay. Now let's understood what is this numerical precision. This numerical precision is nothing but weights. If you are going to load any model, any pre-trained model or any fine-tuned model, then it will load the safe tensors. So it will load the model related safe tensors. That is nothing but these files, these safe tensors files. If you consider this model for this, these are the safe tensor files. So what does the safe tensor files will represent? These represents modal weights. So what are modal weights? These are nothing. While pre-training a model or fine-tuning a model, that model will actually take or pre-trained or fine-tuned on a huge amount of data, and based on that data it will learn relations and patterns, right? Yes. So those relations and patterns it will remember in the form of, or it will store in the form of modal weights. So actually like this it will store. If we observe in detail like how these weights will be stored, these are stored in the form of a numerical representations only by using a numerical precision. So if you take the current condition, then the models will store the model weights in these two numerical precision values, like float 32-bit or float 16-bit. That is, your each value will be represented as float 32 bytes or float 16 bytes. So if we consider the numerical precisions, that is 32 bytes or 16 bytes, then so if we representing the weights in the form of either float 32 or 16 bytes, if we represent this weight in the form of a float 32, then we are taking a huge number of bytes to represent the weight. So we can able to represent the weight in much more effective manner, so that it can be very easy to understand the parameters of the weight or understand the patterns and relations of the weight if we represent in 32 bytes, or else if we represent with less than this, that is 16 bytes, then so since the data is represented in less number of bytes, so it is a bit difficult, but we can save the storage and the processing power, right? Yes, if we use the 16 bytes to represent these weights, then we can able to save the storage as well as compute power also. So while considering a model, this model weights consideration is also important, because so if we use a model with float 32, that is a BF32 type, then it will leads to take a huge amount of storage compared to BF16. So what is a BF32 or 16? This is nothing but brain float value. If you open any open source models like Llama, you can see here BF16. They're using BF16, that is a brain float 16 value. Here B represents brain, F represents floating point value, and 16 represent the number of bytes to represent each and every parameter. This is a top level overview regarding a numerical precision. About while selecting a model, you need to consider this numerical precision. Based on that, your storage will be consumed. So if you are training a model, then you need to understood some more detail about how much storage it is using. So that now understood. Now let's understood how much storage is required to train a model. So based on the parameters, let's consider it. Let's take a 6B parameter values, 6 billion parameters model. So for that, let's say if I am using a numerical precision as 32, if I want to use numerical precision as 32-bit float value, then how much storage does it require to me? So how to represent a value that is a 32 bytes value? 1 bit is equals to how much? 1 bit is equals to 8 bytes. So totally 32 bits. 1 bit is equals to 8 bytes. So totally how many bytes we are using to represent each and every parameter? We are using 32 bytes. Nothing but totally we are using 8 into 4 bytes, right? Yes. So it was 32. So totally 4 bits we are using. Totally how many? 4 bits we are using to represent each and every parameter. So such that how many parameters we are expecting to represent 6 billion parameters. So if we consider it for 6 billion parameters, 6b into 4 bits, then 24 billion bits we need to represent. So that is approximately we need to represent our model by using 24 GB storage. We need to represent our data or our model weights using 24 GB. We require 24 GB in order to represent in order to represent our model related weights. Let's say I want to train this model on float 16-bit numerical precision. Then let's consider how much storage we are using. 1 bit is equals to totally 8 bytes. So in order to represent each and every 16 bytes, we need just 2 bits. We need 2 bits to represent total 16 bytes. Nothing but we need only 2 bits to represent each and every parameter. Since we are expected to represent totally 6 billion parameters, so how many total number of bits it requires is 6 billion into 2 bits, nothing but 12 billion bits we require to represent this 6 billion parameters model representation. Approximately 12 GB we require. If we compare the representation of this 6 billion parameter model with float 32 numerical precision and float 16 numerical precision, then if we represent the same model, that is 6 billion model by using BF32, then it requires 24 GB. Whereas if we represent the same model, or if we configure or if we train the model 6 billion parameters model with BF16 numerical precision, then it requires only 12 GB. That means we are saving half of the amount of storage if we use this float 16 numerical precision compared to float 32. Where So since we are saving the memory, but here a bit compute is more compared to float 32. The reason behind is since we are representing the data, each parameter in less number of bits. So in order to understand the relation in float 16, understand the relation in float 16 or BF16 related models is a bit more complex compared to this float 32 bit. So considering the storage, this float 16 BF16 numerical precision is better compared to BF32. We can even reduce it, like we can even further move to float 8 bit or float 16 bit as well, float 4 bit as well. But nowadays the compute required for those are not present. So currently our compute is optimized for float 32, float 64 and float 16. So in order to design our ML models on top of float 8 bytes or float 4 bytes, we would not have efficient compute models, efficient hardware. So that's why nowadays we are preferring only float 32 or float 16 bytes related hardware, and we are using these precision values in order to train our model. Still we are considering 6 billion parameters model only. But if you come to market, then there will be 22 parameters model and hundreds of billion parameters models are also there. 22 billion parameters as well as 100 billion parameters, like that the models are. So if we consider training of such models, then we might require a lot of memory. That is for 22 billion parameters. In order to train that, we require a storage of 44 GB for parameters, for the weights storing, model weight storing. Or if we consider 100 billion parameters model, then we might require a double, that is 200 GB of storage we require in order to train a model and store the weights. This is regarding storage. But if we consider the compute to process that much amount of storage, we need a bit high amount of compute, right? Yes. So taking these all points into consideration, so we are if you are training a model on your local machine, or if you are training a model on top of a cloud based providing environments, calculate the appropriate storage that you require and calculate the compute that you require to process this much amount of storage, and choose the platform or choose the system that you want to use, and choose the best numerical precision value that fit for your model and train your model. So that's about this numerical precision. If we recap the things, so what is this numerical precision? Nothing but the brain floating value representation of our model weights. So basically, what are the numerical precisions that are preferred right now in market? We are preferring float 32 or float 16, nothing but a BF32 or BF16 values we are preferring. So why we are preferring only those? Because we have hardware resources which are highly optimized for these configurations, float 32-bit values or 16-bit values. And if we train a model, like if we train a 6 billion parameter model, then we also consider the storage, how much storage it requires. If we train this model, these many parameters model with numerical precision of BF32, then we might require 24 GB approximately. Whereas if we consider training the 6 billion parameters model with a numerical precision of BF16, then we just require 12 GB, that is half of the numerical precision of float 32, nothing but BF32. The reason behind this is we are representing each bit in each parameter in 32 bytes here, whereas we are representing each parameter here in the form of 16 bytes. But for both, the accuracy will be same. And here one more point, the output accuracy depends on number of parameters, not based on numerical precision. So we can decrease the numerical precision based on our requirement. We can even further decrease this numerical precision values to represent each parameter value. But the issue that we face with while representing a parameter value with a float 8-bit or float 4-bit is we do not have the hardware that is efficient and compatible for those in order to train our model. So that's why obviously we represent each and every parameter in that way and train our model with available hardware like float 16 or 32 or 64-bit hardware. Then there will be a conversion time, nothing but it will require some compute while converting the data from the parameter represented value, that is either 4-bit BF8 or BF4, to the compatible hardware related numerical precision. That is, if you are using a 64-bit related hardware, then it will convert into 64-bit. We need to convert it, and then further we'll process it and we'll get the results. Even it leads to, if we do this, then it will leads to a late response. It will increase late response and loss of resources. So that's why we're currently preferring this float BF16 as a numerical precision in order to train our models. So also this float 32 bits are also using as numerical precisions while training our model as well. So this is about a numerical precision that we need to consider while selecting a model or while training a model. And this is about the storage related to how much storage will be occupied when we are training a model with corresponding numerical precisions. So while downloading as well, these are the valid ones. So this is all about this numerical precision concept in ML, any models, training any models or selecting any models. I hope you understood this video and you got some good knowledge on it. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.